Pro PCTG, made in the USA, reinforced with glass and carbon fibers. But I will also include the results from my earlier video for no fiber reinforced PCTG. Hello, welcome to my tech fun. I have here two Pro PCTG filaments reinforced with carbon and glass fibers, and these are made in the USA. And I bought these filaments myself, partly from the budget which I got from the Patreon donations, partly from the channel sponsor, the Polymaker. Since these are manufactured in USA and I'm located in EU, the price was quite big for me. The price of the filament itself is not big, $115 for these two spools, and in the USA I think they even have a free shipping or something like that. But for me the shipping was $101. Additionally, because of this tariff and tax and similar, I have to pay additional $76. So this means that with these two filaments I almost exceeded the budget which I got from the Polymaker to buy any filament I want to test. But I don't care, I mean this is the request from many Patreon supporters, and I have many supporters located in the USA. So this is Pro PCTG reinforced with carbon fibers 10%, and this is also Pro PCTG reinforced with glass fibers also 10%, and both are made in the USA. Few months ago I tested their PTG versus PCTG filaments, and I explained there detailedly what is the chemical difference between these two filament types, but also the mechanical difference is explained too. Overall, the PCTG is more ductile material, usually resists better to the impacts. Now adding glass or carbon fibers will make it more brittle, so this means that we will not get this nice property of the non-reinforced PCTG. But in this case it should resist much better to the bending, so the flexural strength and elastic modulus should be much higher. Probably the temperature resistance is better too, and we will see if we have that negative effect on the layer adhesion. Let's see what's in the box. This is carbon fiber version. The second, glass fiber version. On sticker similar informations, the print temperature between 250 and 270 degrees Celsius, bed 80 degrees, and the speed between 50 and 250 millimeters per second. Let's see how brittle are these filaments. Carbon fiber version. Oh, okay, let's measure it. Start angle 20 degrees. Around 110, moderately brittle. Basically it will be fine in any printer, it's not even completely broken. And now glass fiber version. Probably it will not even break in my test. Start angle 20 degrees. No, it's not even completely broken. Carbon fiber typically in black color, because carbon fibers are black and usually we have a black or some very dark color. With the glass fibers we have more freedom because they are transparent, and we can have lighter colors too, and this one is in this nice red color. Now I can see more filament here, so maybe the density of the carbon fiber version is lower compared to the glass fiber, because the spool size should be same. Let's measure them just in case. Theoretically these are both 1 kilogram netto weight spools. 1192, 1170, close. Since this was not vacuum packaging, even if they had some desiccant inside, I will dry these filaments before the printing, and my drying settings will be for PTG, typical 65 degrees Celsius for 6 hours. I don't have anymore their PTG filament from my earlier testing, but I still have this PCTG in brown color without any fiber reinforcement, and I want to reprint some test objects because I have some new equipment and I want to repeat some tests with all three filaments, for example impact or bending test. At that time I didn't do it with that comparison video. Just in case, I started with the drying. PTG setting 65 degrees Celsius 6 hours. 3D Fuel offers a profile for their filaments. This is for the carbon fiber version, and the printing will be on X1 carbon. These are my regular test objects, and let's set that profile. This is the carbon fiber version. I changed the nozzle temperature to 270 because this is the maximum recommended, 80 on the bed, 10 the maximum flow rate, and part cooling between 0 and 10%. No fiber PCTG, the missing test objects. This is carbon fiber version, and this one reinforced with the glass fibers. Printing was perfect in all three cases, and I really like how those fibers hide layer lines. I also printed some test objects for the fatigue test, and this spring I printed from all three materials. The hardware is prepared, only the Arduino and the software not yet. That video coming soon, but I need something now for the practical application example. A spring clip from glass fibers, carbon fiber version. I'm not sure is this good application for this material. That fatigue test will show this in the future. PCTG has great dimensional accuracy, and fibers just helps here. This is carbon fiber version, and this is glass fiber. But let's start with the testing. This is the tensile test, glass fiber version, and carbon fiber version. Between these three materials, the strongest is the carbon fiber version and weakest the glass fiber objects. Layer adhesion with vertically printed objects. And now CF. This was very pleasant surprise because usually fibers makes the cross-section weaker, but it looks like this fiber sticks good somehow to the base material because this is a good layer adhesion according to my rating and stronger compared to the no fiber PCTG. One of the reasons for better layer adhesion of fiber versions is a smaller part cooling, only between 0 and 10%, until with the PCTG it was between 10 and 40%. Shear test side-by-side horizontally printed specimens, and now vertically printed objects. When printed in horizontal position, fibers always helps a lot, and we can see two fiber versions are stronger compared to no fiber PCTG. Printed in vertical position, these are very similar values. Torsion test, horizontally printed objects. 1.1. This was loaded at 90-degree rotation, and now the maximal load. 1.5. Vertically printed specimens. 0.8. The maximal load. 1.1. Printed in horizontal position, loaded 90-degree rotation is very similar in all three cases. Printed in vertical position, only the glass fiber version is a little bit weaker. 3-point bending test. Distance between supports is 50 mm. And I am placing these loads one by one, and I am measuring the deformation after 1, 30 and 60 seconds. Currently you can see the deformation under 10 kilograms. Well, something we could even predict because fibers makes the parts stiffer, and between these two, carbon fiber version is stronger, and very minimal deformation even under 10 kilograms during this 1 minute. Another bending test, no fiber version, glass fiber, and CF version. This describes good these materials. PCTG biggest deformation, no break, smaller deformation before the failure on the glass fiber, and carbon fiber broke. Even these graphs tell us a lot about these materials. The force in function of time or deformation, maximal load, bending strength, and elastic modulus. Similar order we already saw with the previous bending test. The strongest is the carbon fiber version in both bending strength and elastic modulus, second the glass fiber version, and the weakest between these three is no fiber PCTG. Isod impact test, side by side all three materials. With PCTG the first measuring was not recorded, only the angle, so I had to calculate the breaking energy. The other two no problems, all three measurings are visible. Sharpie test, specimen holded on two sides horizontally. and side by side results for all three materials. After a layer adhesion, another pleasant surprise, because usually fibers makes the parts more brittle, but that's not the case here. Both are noticeably tougher compared to no fiber version. Now on my DIY impact tester I could measure 2 times bigger value for raw PCTG, but even this one is 2 times stronger than average PETG. Creep test, the deformation under constant load of 1.25 kg, locking the position for more accurate measuring. 14.52, 13.34. Day 5, the last measuring. 14.88, 13.52. Let's remove the load. Permanent deformation is very minimal and almost equal. On this graph we can see the distance between two reference surfaces, and we can see quite a lot of deformation on the no fiber version of PCTG, and then glass fiber and the smallest deformation on the carbon fiber version. Now the creeping is the difference between 2 days, and that's presented on the second graph, and we can see significantly more creeping on the no fiber version, and the creeping on glass and carbon fibers is very similar. Temperature test in the oven, and 2 on the right side are the PCTG filaments from this video, and they started with the deformation at approximately 94 degrees Celsius. At 128 I stopped the experiment and I opened the oven just to check how soft they are. It's typical that the fibers will increase the temperature resistance, but I didn't expect it so big difference here. All results one more time: creep test, tensile test, layer adhesion, shear test horizontal and vertically printed, bending test, the deformation after 30 seconds, bending test, deformation under these loads after 1, 30 and 60 seconds, torsion test, horizontal and vertical, impact test, ISO and Sharpie, temperature test, and that second bending test. Well, these two fiber-reinforced PCTG filaments was really a pleasant surprise, and almost I could say that it was worth it to pay that expensive shipping from the US to the Europe. Yes, the carbon fiber version is definitely stronger in most cases. Glass fiber, maybe I can see 2 or maybe 3 advantages. One is that a layer adhesion, the difference is not big, but it's there. The second, probably we can have a bigger option for the colors, because the glass fibers are transparent, and we can have, for example, this nice red color too. With carbon fibers we can have only some darker colors, if not black. And the third one, maybe it's not so important, but glass fiber can be dried or pre-dried in a microwave, carbon fiber not. With the PCTG I don't use too often this possibility, but sometimes I can speed up the drying process by pre-drying in a microwave, let's say 2 or 3 times 30 seconds, and then it can go much shorter time into regular filament dryer. Okay, so this was my experience with these PCTG Pro filaments. If you have some other, fill lines down in the comment section. Huge thanks to the Polymaker for their budget and sponsoring the channel, and to all my Patreon supporters, because together they make these kind of videos possible. And to all you others, thank you for watching this video until the end, and happy printing!